Wherever you are, my name is Arun Gupta. I am the Vice President and General Manager for Open Ecosystem at Intel. You can find us all about us at open.intel.com. We also have a wonderful podcast over there, open.intel.com/podcast. Listen to the episodes, and if you want to be a guest, let us know. We would love to engage you over there. Zach, I'm super happy that you are here today.
Me too. Me too. This is a true pleasure. Thank you, Arun, for the invitation, man.
Absolutely. We're going to talk about the universe of Project Jupyter.
That's right.
But before that, before the record, before this thing started, you and I were talking about you were an evolutionary biologist. I
That's
would
right.
love to understand your journey from evolutionary biologist from there to where you are right now in terms of the Jupyter community and a core maintainer. Talk to me about that journey.
Yeah, yeah. So it actually started a little further back in college. So when I was 20 years old, I was a physicist at Cal Poly San Luis Obispo, which is where I live now. I live in San Luis Obispo, California. And my second year of college, I was working in a research lab doing some condensed matter physics and was using MATLAB to analyze my data because that's what they teach physicists at Cal Poly at the time. And got kind of frustrated by the tooling there. One, I was a tinkerer. I wanted, to write my own custom stuff, and that was proving to be hard to do because I didn't have the money to buy the more expensive license for the software I needed, not just MATLAB, but some other tools. And I also was just not a good experimentalist. I was in an experimental physics lab, and I was dropping things, and so it was safer for me to be at a keyboard. So I started doing some computational physics in that lab and picking up some tools there. And at Cal Poly, I met this professor. His name's Brian Granger. People who know Jupyter will know Brian. He he actually like wrote the original V1 of the Jupyter Notebook. It was kind of his brainchild, along with his good friend and colleague Fernando Perez out of Berkeley. They were both professors that collaborated on this project. So I met him. He was like, I got this crazy idea. We were, you know, nerding out because I was a student in his quantum mechanics class, and I was showing him my research just as you do with a professor in office hours. And he was like, you should check out this tool I'm working on. So we started doing it on the side. I taught myself the program. So I have no formal computer science background. Did that. Then I went and I helped him write kind of the first version of the notebook, parts of it. I mean, he did most of it. I just helped with certain portions, and there was a couple other students that I was collaborating with. I went to graduate school because we didn't. This was just a side hustle, and I was really a scientist at heart. Jupyter was just at the time my Python notebook was just a tool help me do my research better, and it was easy to use and free, and there was a lot of hacking opportunity on it. And so I went and did a PhD at the University of Oregon in evolutionary biology, evolutionary biophysics, really. And again, I was a computationalist in a completely experimental lab. They were very excited to have somebody with some analytical background, some quantitative background to do some statistical analysis for their data sets. And they were just great biochemists. And they were studying how molecules evolve over long periods of time, proteins specifically. And what I got to do is I got to pull this project out of my college days, show it to them, and be like, what was so attractive, and we're going to talk about that, I think, today, immediately for them, was that Jupyter notebooks don't quite look like normal software documents. They don't look like source code. And I was working with people that were experimental researchers. They didn't have, you know, the technical skills for like programming and things like that. So it became a medium through which I could help them analyze their data, write reproducible calculations on their large data sets, but they could read it. It was very human readable and shareable, and they could go and run it on their computer, and it just worked. And so that really helped me decide to lean in. Like, this is a tool I think is so important in the research and scientific communities. And so I just leaned into that and continued to do this as a side hustle. Don't tell my PhD advisor. But worked on this. And then when I finished graduate school, I really had this kind of decision: do I go down the science, or do I go back to work on the Jupyter track? And so at the time it was pretty tough, but I ended up calling up Brian, and we started a team. Well, he had actually had a team running at Cal Poly now of multiple Cal Poly students, and he wanted someone to come in and help lead the engineering side of that research project, where they just worked full time on building Jupyter components. And so I came in and ran that division for a while, and then I got picked up at Apple to kind of help them do the same, continue to push the project forward um, from Apple's seat. And so that's kind of my long trajectory to the project. We'll get into why I love this project so much that really I think weaves into that narrative as well.
That's fantastic, actually. I mean, what I'm seeing is me search to research to your actual job now,
Yep,
driving that as a common thread. And that's a
100%.
quite an entertaining story. And by the way, I know Brian as well because when Amazon hired him at that point, I mean, I was driving some of the open source strategies for Amazon. So Brian and I chatted at that point of time.
Yeah,
I remember having actually a coffee with Brian, in the Palo Alto campus of Amazon. And he's saying, Arun, what does Amazon think about open source? Let me understand about the culture. So, yeah. Hello, Brian. And hopefully I'll bump into him somewhere. So that's fantastic.
100%. 100% you will. We'll
That's
make it
awesome.
happen.
That's super. So,
Yeah.
fantastic. Now, today we are talking about Project Jupyter. And as I understand, Project Jupyter is multiple components. Talk
Yes.
me through that part of it. What is Project Jupyter about?
Yeah, that's great. So why don't I just go ahead and share screen, because I told Arun we're going to take a risk today. We're going to do some live coding. I think that's just the best way to show off these tools. So let me make sure I got the right window
So
here.
just to kind of highlight the risk part of it, um, you have used Jupyter notebooks for a long time,
That's
but
right.
for more recently, you have been building the Jupyter notebook. So we're going to find out what the skills are for using the notebook now.
That's right. That's right. So I do have some slides prepared. They're rough, but again, uh, maybe it'll help drive our conversation. But the heart of this uh, this meeting today was, I told Arun that I run this thing called Contributing Hour in the Jupyter community. And that the idea is, we have a lot of folks ask us how they can get involved in the project because they love it, or they just interested in learning, picking up these skills in the open source. And so we started hosting this hour where we just live code. And we feel the best way for folks to learn is to just see it happen in real time, watch people with a little bit more experience fumble, so it makes everyone feel a little bit more like, okay, I don't have to know it all. I can kind of fumble my way through these tools, and that's how I learn. And so seeing that in real time is helpful. So that's what I'm doing today. So I used to write a lot of notebooks back in the day, as much as I developed them. Now I almost never write notebooks, and just work on developing them. And so I felt like this would be a good exercise to go back to my undergraduate days when I first discovered the Python notebook, or now called Jupyter Notebook, and see what I can learn. So we're going to learn it in real time. So the prep for this has been very minimal on purpose. I wanted to see, what I could do live, and I'm starting completely here. Let's get a clean slate here. Um, I'm truly go back to the basics. So the only thing you maybe need to know to follow along would be, using something like Conda. I use this thing called Mamba, to do all my installation. And so I'll show that really quick. But you can go to this GitHub page, MiniForge, and pull down one of these um, installers for your particular platform. And just choose it. Like, you don't even think about this. Just choose one of these and get them down, and it'll set you up just fine. Even if you're just using Jupyter or you're developing Jupyter, this tends to be the simplest way to do it. So I'm going super scratch. Um,
So this
and
is going to set up the environment on your local machine so that you can start using Jupyter.
that's right. So you don't necessarily have to know what that did, other than it does create. I'm going to follow the instructions. You'll see that it tells my terminal, hey, you've got something here called JupyterLab that you just installed, and I just activated it. And you can just think about this as, this is like my project folder now. It's got everything I'm going to work on from now on in this talk is going to be underneath this folder, and I can wipe this at the end of the talk. That's really the main goal here. But this doesn't have anything. It's just an empty folder. We call it virtual environment. It doesn't even have Python, so I have to install Python. You're gonna need Python to work in Jupyter. So I'm gonna tell it, let's give me the latest Python, stable Python 3.10. I guess we're on Python 3.11 now, but we'll
So
start with.
take a step back for a second. We are installing this environment, and Jupyter, as I understand, consists of three components. There is a Jupyter Notebook,
Yes,
there is a Jupyter Lab, and
that's
then
right.
there is a Jupyter Hub. Is
That's
it
right.
just going to install all the three components, or is it installing one or the other? What's going on here?
Yeah, so I'm one of the bare minimum requirement you need for Jupyter is you need a Python running on your system. So I'm starting there. I'm getting Python going, and then I'm going to start by installing JupyterLab, um, which will give me Jupyter Notebook as well. So
Oh, these are separate components that you're going to install. I see. Okay.
yeah, you can think about them as two different um, applications for writing notebooks. And so the reason why I go to JupyterLab is JupyterLab, it's a little bit more advanced. The Jupyter Notebook, and you know what? Let's just do Jupyter Notebook. So if I do pip install notebook, I know this font's probably too small, but if I pip install notebook, I'll get this thing. Take a second. That I can open. You know what? And I'm gonna, because we're gonna get there, I'm gonna install NumPy, Pandas. I won't, talk necessarily specifically about what each of these things are. I'll just demo them for you. I'm gonna do another one called IPy widgets. We'll get to that, but I'm just gonna install a few of those. These are just numerical libraries and libraries that a lot of people use for data analysis, data science, plotting, things like that. If I just do Jupyter Notebook, so I just installed Notebook. If I type Jupyter Notebook on my command line, it'll open up a browser and it'll show you my files that I'm in. And this is the classic interface that we've always had. This is what people know when they think of the Jupyter Notebook. What you get is this UI that shows a blank sheet of paper. It looks slightly different than like a Google Doc, or some sort of word processor, in that there seems to be this box around here where I can type stuff. But what I'm typing happens to be, as you see labeled here, code. All right, so code, what does that mean? Well, you can type anything in here that you want to compute. So I'm just going to put 2 plus 2 and see what happens.
And is that like a Python code, or what kind of code it is?
Yeah, so good question. Jupyter's by default is going to install Python out of the box. And so this document that you're seeing is uh, a somewhat human readable document. We'll get to that a little bit in a second. But behind it, it's actually talking to a runtime of some sort, and the default is Python. And it shows you that by listing it up here in the right corner. So this is
I
running
see.
Python
And I
3.
believe there are other language kernels that can be installed, Java, whatever comes to your
Right.
mind, that you need, that'll make the Jupyter notebook interpret and parse that language accordingly.
Exactly. So in the early days when we wrote this thing, we called it IPython, which stirred up a little trouble with Apple, jokingly, during the iPod days. No, I'm just kidding there. But it was a Python based document, computational document. Um, Along the way, we realized you can abstract out the document, the actual web application document that you see here, to run any language. There's nothing in principle that stops you from running anything in the background. And so the languages that you can run in these, what we call code cells, these blocks of code, could be any language in principle. In fact, there's C++ kernels, which is mind blowing to me. There's Java, Scala, R, name the programming language, there's probably a Jupyter kernel for it. Kernel is
And
the language we use.
and the primary audience for the Jupyter notebook is research scientists, as I understand. But it is really meant for anybody that they want to experiment with it, because code is just one element of it.
Oh man, yeah, you're preaching, man. This is as a physicist in college who had never been exposed to programming before. I remember sitting in 10th grade and getting a graphing calculator for the first time and being like, oh my gosh, this can plot a sine wave. This is mind blowing. Like I was having to manually draw points before this until someone showed me the power of using a graphing calculator.
Right.
So that's what Jupyter Notebooks became for me. I'm writing 2 plus 2. I don't know what language that is, but if I just hit play, in this case, it's Shift Enter when I'm in that cell, it just output the answer. There's 2 plus 2 equals 4. Like this thing's computing. And I can go back and change that value and rerun it, and I get a different answer. And then I can do some mathematical operations. Like I can create variables and say, this is y is +5, and then I can tell it to print that. And so this feels really natural as a person who is kind of in the math and science space, as a tool that's like, oh, now I can compute things much more easily, and it's readable, and it's in a document that feels similar to documents I've used, like word processing apps. Um, and in fact, we're going to talk about there's different types of cells. We have something called Markdown and raw. So in general, what is Markdown? Well, if I just type something that looks human readable, this is a cell. Just put a sentence in there. It gets rendered in a rich way. It looks like something I would see on a website. You know, there's some syntax in here you have to learn, so we won't go into that too much. But Markdown is a syntax you can leverage to create styled text output. So I can say, like, this is a header, right? And now you got a big header there. And these
This is very
documents,
intuitive, for somebody who's sitting into the university in the research side, or who doesn't have a programming background, but they want to get something done. You're giving them this interface using Jupyter Notebook, essentially. They don't have to worry about what kernels, what languages, what modules to be installed. Somebody in the back end could come in, get all of that configured and set up for them, and they say, you just figure out what you want to get done and then get it done.
that's exactly right. And you can start to do, scientists know this markup language called LaTeX, right? And I can say, if I type in that, Jupyter, like, we somewhat cater to the scientist, to the researcher, because that's who we are. So everyone who wrote, notebooks in the early days, like, who wrote these things, they were academic scientists, students, and grad students. Um, that's not exactly what it looks like today, but in the early days, that's who wrote the Jupyter Notebook. They were just scientists. They weren't actually software engineers. And so they built an application that really was empowering those kinds of groups. And, one more thing let me just, because we're on this topic, I'll just do it in here. So back to pip, I could say pip install. I want to do a library called NumPy, because this will really speak to, the sophomore in college that I was. This is one of my favorite libraries. I almost never get to use it anymore, but man, does it speak to the young me. So NumPy is basically a symbolic programming language. So what I mean by that is uh, I can create a symbol, X. You can see it's printed nice and pretty.
Huh.
I can say Y equals, it has a bunch of mathematical um, methods and functions in it as well. If I say sine of X and then print Y, I've got a rich. Now here's where it gets crazy. What if I just plot Y? I'm going to get a function.
Wow.
This is symbolically computed. What's even crazier is, it doesn't stop there. What if I, want to, there's this function called diff, if I remember. I think it's still diff. I'll just put a question mark. That'll show me some info. Yeah, this is how I differentiate the function. This is a integral. I mean, sorry, a derivative. Meaning that if I do, what is the derivative of y? Oh, it's cosine. It absolutely is. How great is that? Well, why don't we just, take y prime then and call it sympy of y, and then I'll just plot these guys against each other. All right, so notice that I'm going back up to cells I've already written and edit them, and then running them again. This is kind of that the iterative interactive portion of notebooks that's really strong, right? You can't really do that in a script as easily. You have to go and rerun the whole script from scratch and comment out pieces you don't want. But in Jupyter, you get to kind of, you feel like a scientist. You get to try something and experiment in something in this little container. And then once you feel you're happy with it, you move on to the next thing. But here I just, symbolically plotted both the function y and its derivative. You can do integrals and so on. Anyways, I discovered this, and I mean, okay, go with me one more. I'm nerding out
I think
crazy.
the power that I'm seeing here is, usually I will have my notes somewhere, formula somewhere, then I have to kind of figure out where my terminal is. It's all scattered, and my brain is kind of looking across multiple windows. Here, everything is all together into a unified interface.
Yes,
As thoughts are coming to my head, I can just quickly create a scratch Jupyter notebook, play around with it, see what works, and then say, okay, now I'm ready to actually take this into better mode, like production or whatever, right?
exactly. And this is a document at the end of the day that's shareable. And so one of the real strengths here is that what you get is something that if I were to share with someone who's not necessarily a programmer, they're a scientist or there's someone who's interested in the ideas that I'm creating here, they can still take this document and consume it and understand it. They can ignore the code pieces if these things look like gibberish to them, but the outputs are telling a story. So there's an underlying narrative here that this document is creating that really can bring both the computational scientist, which was me, right? I was a computational scientist sitting in a research lab. I could do these analysis leveraging computation and then create an output or a consumable report that then my colleagues could read who didn't care about the code, they just cared about the conclusions. And then if they did want to know how I did it, they could go back and read the code or start to play with variables and change it. Um, and then, just to take it a step further with the interactivity of Jupyter, we built this thing, let's just, what's in here? You can see all these cool things like buttons and boxes and sliders. But I just want to show this because this is like, you know, I don't get to do this often, and this is fun for me. But let's just create a slider. We'll call it S. What did I just create? So I just typed it up. If I just print it here, oh, here, this is cool. I've got this little widget on the page that's interactive. Okay, well, let's do something with that. How about let's take that SymPy function. So I'm going to create a little interactive function, and I'm going to give it, let's call it A. I don't know. And we already have an X, right? So I'll just make Y equal X, and we'll make the exponent of that be a variable, and then we'll just plot Y. Okay, I don't know if this is going to work, but so I've defined my function there, and then there's this other thing in widgets, IPy widgets, that says, hey, give me a function, and then you want the variables to be a widget, we'll just point that widget at that variable. So, I defined A in here, and then maybe let's call this slider so it's, a little bit more clear. I think if I just pass some
Good naming
slider,
convention. Yeah.
okay, whoa, I got this cool, I got the function plotted, and I got the slider bar. What happens if I change it? Oh, what am I missing here? Mm, it's not updating. Got to live debug this. That not work? Hmm. I went I went a little risky here.
So line 11 already talks about diff of y. I wonder if we declared y above.
Yeah, you're right. This could be a state problem, Let's call it F. I don't know.
Yeah.
No, it's not
No.
updating. It could be this. Let's pop into JupyterLab. This might be a bug I discovered in here. Does that work?
Oh, there you go.
I've got an error here. I bet it's because, try one more thing. If this doesn't work, it's okay. I
That's
just
fine.
figured I wanted to demonstrate, that we get this.
It says something at the bottom. Widget model not found.
We'll give ourselves a slider again.
Oh, okay.
That work? There we go.
There you go. All right.
Yeah, sorry that took so long, but yeah, so you can see the functions change interactively as we plot. So this is the kind of stuff where I'm like, all of a sudden I can also create these documents that live and breathe based on how people consume it. And the data doesn't have to be static. The document doesn't have to be static. This is something publishable. That's notebooks. That's the concept of computational notebooks. Wasn't invented by Jupyter. Jupyter just ended up being probably the most popular open source implementation of it. The idea of creating computation notebooks predates Jupyter, but if you think about it in the context of human literacy, 30 years ago you couldn't even conceive of this. It was like there used to be people wrote on on pieces of paper, hand wrote, and then you had the printing press come along. You have this ability to publish things really fast and create copies that a lot of people consume. And then you have the word processor come on. It's a typewriter, word processor. Work your way through the history of how people have been able and empowered to write, and now put computational notebooks in that narrative. It's bringing computation to writing. Enables people to communicate ideas that are much bigger and living and breathing that they didn't used to be able to communicate with just a simple static page.
Yeah, no, I mean, I think you put it very well because what Jupyter Notebook has done is sort of the tipping point. Computational notebook as a concept has existed for a little while, but it has just become the tipping point where it's just commoditized it. You want to draw your computational notebook, put your thoughts in here, and we'll just spit out the output for you, and that's what it is. Himanshu dropped a comment in the chat. It says, Jupyter has unlocked the power of Python programming for so many folks.
Yeah, yeah, that's right. I've witnessed that. I've sat in graduate, as a graduate student, I had to do a teaching assignment, and one of my teaching assignments quickly became teaching scientists how to program. Right, and we didn't start in an editor. We started in Jupyter Notebooks just because it got them there faster, and then it became the tool that felt more natural for their flow. And I think I did have slides, but I like that we aren't using them. I I do want to mention Jupyter Hub is another component which sits kind of higher up the stack, which is this idea that if you're a person who has an organization, like a research institution or a company who wants to provide notebooks as a service to your users, Hub is kind of an all batteries included way to spawn individual notebook server and accounts for them, and that's full open source. It's amazing.
And
Um,
so an organization could potentially set up a Jupyter Hub inside their company so that only people within that organization has access to it.
that's correct. That's correct. And so that was, really at the end of the day, what we wanted to get to is allow research labs to have a single one shop stop, install this thing and you can run this for your research group. And of
Got it.
course, that's been extrapolated out to be, run inside of organizations everywhere. We talked about, all these things about the interface. I'm just going through this because you had said something that triggered it for me. Yeah, I said all this, right? You can compute things, you could tell a story, invite others to try your thing. I talked about this. So just wanted to highlight this because I love this. There's this thing written by this is a high school student that I worked with back in the day who discovered notebooks as a high school student at the height of the 2020 pandemic,
Wow.
June of 2020. And so she just went out and wrote a book out of notebooks. This is a live web page you can visit. You can tell that there's some, learning that's in terms of estimating, but like here's some live graphs that she built out of notebooks
That's
describing,
amazing.
and you can see the code she wrote as a junior in high school that led to, you can see she's using Pandas and she's fetching the data and she's grabbing like county infection rates. And she was trying to ask the question, like, are we actually flattening the curve? She could go and try to answer that for herself. She didn't need to read somewhere else. And she did this data analysis looking at different counties, and looking at how the thing spreads, fitting curves to it, right? Just mind-blowing stuff. Obviously, she was very talented as well, but just basic math, curve fitting and stuff like that, and then published it into a book and put it out there for the world. And so it's stuff like that. Speaking to the comment in the chat about how it's empowered people, I mean, it really has, right? That this is a new way of communicating ideas, that I think sometimes we take for granted, um, and it's not for everyone. Like as a software engineer, I don't think you're going to use this tool, um, to do production ready software engineering. You maybe could shoehorn it in, but this is for the scientists. This is for the creative, exploration of data and information and building analysis around that. It's probably better suited for that. You could also do that with software engineering tools, but it may not be as natural. Um,
Yeah, no, I think as you said very well, this is sort of about that tipping point, that commoditization of computational notebooks. That you want to do this, don't worry about whether you're running on a Mac or a Windows. What do you need to set up? What libraries you need to install? Here's a pre-set up Jupyter notebook for you. Just do the thing that you are more focused on, and that will get you going.
that's right. That's right. So, uh, yeah, so we talked about notebooks. I mean, this gives you the best intro to a notebook you can get in terms of like what the interface is just seeing it kind of raw developed as you go. And then you can start to, experiment in one and then start to clean it up afterwards. I think that's the flow I see a lot of people do is after they iterate in a notebook, they go back and clean it up and start to merge cells together if they need to. The last component I think we talked about is this idea of JupyterLab. So JupyterLab is, kind of you can think of it like an IDE for notebooks. So it's an application that's focused on making the notebook editing experience more, expanded and more powerful. So it has kind of a file browser next to it. That's a simple thing that the classic notebook didn't have, right? Is you have to like open a file by going back, and looking at, a separate window for the files that are around it. You can just do that right here, and open up a notebook. So here's the one we've been editing. Um, you can do things like put two notebooks side by side. So it just makes the interface a little bit more smooth. And these are integrated. Like I can drag a cell and you can see it created a copy over in the other notebook. And so it just provides kind of some of those really useful aspects, for working with multiple notebooks and having kind of a more advanced workflow system. Um, there is a whole ecosystem of plugins that JupyterLab has as well. And so you'll see we have this little plugin icon, and that opens up, a panel that shows you what plugins you currently have installed, and then you can go ahead and search, for plugins that exist out there in the world. Um, and so anybody can write a plugin if you publish it under, an open and public archive. In this case, these are all being pulled from PyPI. So you bundle your extension as a PyPI package, and it can be fetched and installed.
So, what are some common plugins that developers have written or that are common across the community?
Yeah, it's a good question. So interestingly, what often happens is someone develops something, and if it becomes useful enough, it just gets folded into core. So I want to mention that everything in JupyterLab is a plugin, including the notebook.
Hmm.
JupyterLab you can think of it as like an empty desktop for, and it's a web application, which is, when you think about the layout system of each one of these panels, they essentially invented a blank canvas that feels like a desktop inside a browser, and then everything else is just plugged in and integrated. And so anyone can write a plugin, yes. If it becomes interesting enough, generally it gets folded in. Probably the most common ones, uh, people really like the version control their notebooks. And so there's a Git plugin. You can go ahead and install that.
Yeah, actually,
That
I was wondering about that. As a scientist, as I'm playing around with my Jupyter Notebook, I've done some scratch work. I'm going back and forth between the code. Now I think it's looking good. What is the mechanism over there? How do I save my notebook in Git or whatever repo it is, and then kind of share it with others? How does that developer workflow look like?
yeah, and that's you are touching on a weak spot of the notebook ecosystem. One of the challenging things about notebooks is the file format of the notebook. Um, the file extension is IPyMB, but if you can actually open and see what it looks like, it's just JSON. So it's a highly nested um, a data structure written on disk. It's powerful for many ways. One, is nested. That's super helpful. Two, you can really hook in all kinds of tooling around JSON, and you can schematize this so you can ensure and validate the file format, things like that. But it presents a problem for version control, and so we had to somewhat invent our own versioning tool that acts as a hook into Git to do version controlling on notebooks. So there's a tool, I think it's called mbdime, that you can install, and this will do kind of the diffing you need to version control notebooks. Otherwise, everything around Git, just checking in notebooks and merging them in and pushing them to GitHub, works just like normal. But when you're trying to compare changes that someone else has made, it can get really ugly. So mbdime is the tool under the hood that allows you to do these diffs. But probably the most common use case for people is that they just install something like this Git extension. They'll initialize a repo. You can point this at a public repo. So if I were to point this at a GitHub repo, I could push and pull from it. You can see this is a UI for Git, right? There's a bunch of untracked files. So I want to track my notebook that we just created, which is titled Untitled. So I could add that, add a notebook. Don't mind my typo. Commit that, right? And now we've got that file staged, and it's there, and you'll see there's my history showing the change I made. Now, so I've got the full Git flow in a UI. If I go and change this, let's change some numbers. Um, we'll change this function to cosine and do the diff. Okay, so now if I go back to that diff panel, you'll see that I have some changes on that file that have gotten tracked. So I can go ahead and look at those changes in a rich way. So this says, look, the output was deleted and a new one was added, and here's the difference.
Yeah, the usual Git diff, basically.
Exactly. And
Yeah.
some of the changes can be on just the metadata themselves, but you can see sine and cosine. I mean, so there is a flow for diffing and tracking notebooks, and you can do it all inside of JupyterLab. And it works with not just notebooks. I mean, you can do this with Python files and stuff like that as well. And then, if you stay in JupyterLab, you can handle all of this from the UI. You can push it up to your repo and pull it down from a repo, um, all within here.
So what gets stored in the Git repo is essentially that JSON representation, the IPYNB file,
That's right.
because that's the JSON representation that goes up. And what you're seeing on the Jupyter Lab is really the rendering of that repo.
That's right. That's right. So, go back. Let me see if I have a repo I can point us to on my own account. I'll show you what they look like. Yes, you're pushing the raw JSON up there, and then they're rendering it. And we got in good with the GitHub guys in the early days. We were like one of the first big projects, I think, in the early days of GitHub. So we were like one of their test runs. Um, and I have, just to talk about how cool that this works. This was a repo I created 11 years ago. It was after I graduated from college, but this is my undergraduate thesis, my condensed matter physics. It's just a bunch of notebooks. So there you can see my IPyMB files, and I can go and look at one of these. And GitHub actually has a rendering engine on their side to show the notebooks there. So here's my notebook saved in this repo, and 11 years later, the same document still works on GitHub with math equations, with functions. And so this is forever posted, and maybe you shouldn't go and try to repeat my experiments, but they are there if you want to.
And so this rendering engine on GitHub is built into the github.com website itself. So if I go
Correct.
to the repo, I'll see a similar rendering.
That's right. That's right. And this has historically not always been the most stable thing. Like that, sometimes they'll get out of date with our version of the notebook, and so then things will break temporarily. But generally, the relationship with GitHub has been like great. They usually like work on this and get it updated pretty quickly. And so I wouldn't recommend using this as the place to share notebooks. That especially if your notebook starts to get really really large, rendering will take a while.
So what is the recommended way by which developers share their notebook if this is not the recommended one?
Okay, so there's many answers to this question. The most likely one would be we do have a service that Jupyter provides, but it's shouldered and maintained by a small group of people, but it's called MB Viewer. MB Viewer allows you to paste a GitHub URL and view the notebook. So let's try it with my thesis repo here. I don't know if this will work. And this will take that repo, fetch that content, and render it. I did pretty good. So here you have a static view of those notebooks. Let's see if it actually renders my notebook. Yeah, there it is.
There you go.
So it does a pretty good job at rendering these things, and it's just a service that Jupyter provides for free. You can point people at this fixed URL, and it will always pull from your GitHub repo. So it's a link that in principle will live forever. You'll see we also offer this service called Binder. So Binder is this. It's free. It'll actually build a runnable, so it's this pulling down a Docker container and building a runnable version of these notebooks. And so these take a little while to spin up because it's actually having to pull down an image and start a container. And these are backed by, we've had time on Google Cloud. There's a few other different cloud services that kind of share the load for us. And yeah, it'll give you a running JupyterLab with those notebooks ready to execute. It's a little dependent on you to have the right configuration files to make sure that you get the things you need installed on it. I don't have that in this repo, so these notebooks won't run. But in other notebooks, other repos, I do have that. And so you can share a link to what we call a binder, and a binder will give people a live instance. Let's see if I have an example of this. Yeah, you can see you can add this little badge. Binder has a place you can go to create a badge that will automatically spin up a live instance of that repo for them, and it will
Gotcha.
share those notebooks.
Gotcha. Fantastic. Now
Yeah.
we have about 15 minutes remaining. I want to
Okay.
switch the discussion, on LLMs. You know, anybody and everybody is creating these LLMs or fine tuning them or applying RAGs to
Yeah.
make it work for them. What role does Jupyter Notebook play in that ecosystem?
Okay. Caveat here is that all of this is my opinion, because there's definitely differing opinions in the community. Generally, people that come to the Jupyter community are tinkerers and exploring, different things. So there are people who are certainly exploring how do I integrate notebooks and LLMs from how do I use it to hint code and infer what is the code that you're writing? How can I get a chatbot right in there that answer my questions? And so there is that. There's a project called Jupyter AI. it was actually developed by Brian's team at AWS that can hook into your favorite LLM, and it can start to work with you as a little coding assistant inside of JupyterLab. So if you want that, they have that. It's great. I've used that and it's been fun. But I think the deeper question is in the world of evolving LLMs, people building LLMs, kind of in the process of actually building AI in general. Where do notebooks exist as a tool in that tool chain?
Correct.
We did so I actually a couple months ago where I saw you, this is how probably we got connected again, was at KubeCon. We gave a talk really addressing this particular topic kind of as a side offshoot of the conversation, which was with the kind of onset of Gen AI becoming such a central focus for a lot of engineers. We don't believe the future is less humans, more machines. It's really humans doing more interesting things with machines. And so
Okay.
we presented this kind of outlook on the future. This is our theory about what the future will look like. And it was, I think what we should be building is more human in the loop data science or AI ML, where Jupyter really is a tool that inserts humans into the execution loop. It says humans get to interact exactly where they want in the code, and it's better than a breakpoint. It's more interactive. I think building AI ML, that's in order to do this well. What we don't want to do is take the human out of the equation. We want the human to be baked right into the middle of it, getting their hands dirty with thinking about these things. And so my bet would be that if we were to be able to see the tools that many of these AI ML engineers are using, I would imagine that notebooks are rampant in that space. People are writing a lot of notebooks, exploring both how to build out AI ML and also how to evaluate it from both a how's it doing from a technical perspective, how's it doing from an ethical perspective. There's just all the research that's going on around AI ML. I'm going to guess that notebooks are in there a lot more than people want to admit too. I think people sometimes give notebooks a tough name because they are a little bit of a break from the classic way of thinking about software engineering. And that's okay. I think they're not meant to be software engineering tools. They're tools for scientists. And I believe we're all scientists. And that was the other premise of the talk: is everyone is a scientist. Yeah, we got to go and productionize things and engineer things and create a stable production stream at the end of the day. But in that early phase of experimenting in notebooks, I think they're just a tool that's strong for that. And so in the AI ML world, I think a lot of AI ML is being built on notebooks, at least in the research phase of that work. Productionizing, probably not. Maybe it shouldn't be. I think there's some pretty cool things. There was a blog that came out from Netflix like a few years ago where they were showing off how they were building pipelines of notebooks, and they were literally having production workflows generated entirely of notebooks, which felt like a hack on notebooks. Like, oh, I don't know, like I felt uncomfortable reading it, being like, I'm not sure that's what you should be doing. Like, are they really meant to do that? But the bonus of it was that when they needed to tweak something a year from now or 2 years from now, or maybe they saw something going wrong in their analysis, the pipeline of notebooks provided a very human accessible, human readable record of exactly what they're doing in the logic stream. And so they could go back and read a document, a Jupyter Notebook, but it's a document that they didn't have to go fumbling through source code per se. They could actually read the intentions of the person that wrote that part of the pipeline in a way that the author, could somewhat mix documentation and code. And so maybe one argument for notebooks being more involved in a lot of this research and a lot of these development in pipelines is that it does bring in the human element, and I don't think we should write out the human element.
No, I think you're absolutely right because, gosh, back when computers were introduced, then the internet was introduced. All along there have been discussions that, oh, it's going to make humans redundant. Well, we have survived those and we're going to survive this as well. So
I
it's
agree.
just that, as you were saying correctly, we're going to end up doing more interesting things because I'm not going to be like, worried about how my code is going to look, what the bugs are going to be. Hopefully, my chat GPT can figure that part out for me, make things simpler, but I can just evolve into it gets into like I was listening to the Hard Fork podcast this morning, and they were talking about prompt transformation. So essentially, you give a prompt to ChatGPT. Behind the scenes, they were talking about Google Gemini specifically. Like you say, I want a white bear, snowboarding, for example. Then they will take that prompt. They will do the prompt transformation in the backend. Make sure the bear looks fluffy. Make sure it's on the high mountain. Make sure it's a slope. So they do that prompt transformation without your knowledge, and that's not right. I think that's
Yeah,
where the humans had to kick in, and that's where I think the relevance is definitely going to be there, where we'll end up solving harder problems which machines cannot solve. So I think your
I
point
agree.
is absolutely relevant. On the same note, I would love to figure out, like, as a research scientist, let's say I've done my work around creating the pipeline. Okay, that's all good. Now my experiment looks great. How do I take that into production from Notebook then? What's my next step? Is it like, do I give that to a ML ops person who then containerize it and put it into Kubernetes? What does that pipeline look like?
Probably realistically, yeah, today. I mean, um, what I've seen coming out of many companies, like, who are sharing it through blogs and stuff, is that in some sense, there is tooling that exists in Jupyter that people are exploring. There's a project um, in the Jupyter ecosystem that's governed by Jupyter and it's open source called Jupyter Scheduler, which creates the both the REST API, the schema for how do you build what they would call scheduled notebooks or scheduled pipelines. Like, we wanted to find Jupyter is really in the business of how do you develop um, a verbiage, for interactive computing, and we have reference implementations that say, as long as you follow these rules, we'll give you the one out of the box. But you don't. I mean, you could go write your own from scratch as long as you adhere to the contracts that we've defined. Your thing will work in our ecosystem. And so, when it comes to that productionizing, I don't think that Jupyter is necessarily going to solve the problem of like how do you. I think you do have to work with an ML ops engineer to go and put this up on a system. Unfortunately, I don't think there's a way around that. But Jupyter's kind of promise is that we're doing our best to develop a sustainable future for this, meaning like we're going to develop schemas, verbs, messaging protocols and specs, so that notebooks written today and pipelines written today and tooling around that pipeline written today will work 10 years from now. And that's one of the most interesting things for me, transitioning out of fully open source to working partly at different companies, has been writing code inside the company and writing side in open source is a wildly different experience, right? In open source, I am constantly thinking about how does this code work 10 years from now? And I know that because I wrote code 10 years ago and I'm still paying for it today. Uh, but inside the company, you can iterate a little faster and there's not as much risk because you control the whole everyone who uses it. Um, and so that also made me think differently about what am I supposed to do out in the open source. It's really to focus on the places where having one person take an opinion on this, or one company or one organization or institution take an opinion on this, isn't going to be helpful because it's not going to serve the needs of the many. So how do I foster um, places in technology around Jupyter where we need all those perspectives to share and develop a common solution for everyone, and that's where we operate. So I think in the AI that has a lot of, there's places where that's what Jupyter AI is trying to do. They're trying to define like um, a set of protocols and schemas and expectations for how notebooks will plug in with LLMs, and then same with scheduling notebooks and pipelining notebooks. It's like we're just there to define the messaging protocols and specs.
And on top of that is where the tooling is going to evolve essentially.
Yeah, and if you have two implementations, great. If you have five implementations, great. It's totally fine. In fact, that's why there's, we have like over 100 language kernels that can run behind the notebook, any language, and there's multiple Python kernels. People have implemented different versions of the Python kernel, and the reason why all of those can work underneath the notebook is because we define the contract between the notebook and the document and the runtime kernel, and that's all we want to do. We just want to give folks the kind of neutral. Here's the language you need to speak, and as long as you speak our language, you can do it. You can do whatever you want underneath it.
Yeah, it's like a REST API. You have defined the API, you go figure out
Exactly.
how you're going to implement it, what language, we don't care. You
Yep.
just talk to us that language and we are golden on that.
That's exactly right. And we think about that at every layer of the stack. Widgets, the little interactive widgets, they have a schema so that you could go write your own widget library, and we can render it in the front end. And so we just look for opportunities to really abstract out that the reference implementation from the specs. And so that's we're in the business of that. That's the place to get involved. Help us develop those things.
I was actually coming to that. Where do you see Jupyter? I know it's kind of hard to ask that question for any open source project 5 years from now. Nobody knows where the project is going to be 5 years from now. Nobody had predicted AI is going to be such a big craze 2 years ago, as a matter of fact. So,
Right.
but what are some general future directions that you're heading to as you're looking at Project Jupyter? Like, what are the goals for this year?
Yeah, I think well, I think so. There's been a huge refactor in our how we structured our open source governance, and the hope there was to invite people in, more people in, to just help with leadership roles. Um, so I think growing the community, like that's a huge focus. There's a working group that was just launched this last year, focused on growing the community. Like, how do we do that? What are the strategies we need to learn from others? So that's one. But from a technical perspective, I think probably the efforts have been moving towards notebooks are great for creating like your own ideas and sharing them with people by emailing a document. But every word processor app on the planet tries to create a real-time experience. Jupyter's not, we're essentially a word processing app with some code baked in, and so we've been trying to solve the real-time collaboration problem forever in notebooks. And so I think that Jupyter notebooks are a complex document to implement that in, because there's more than just text that you're comparing. There's outputs, there's widgets, there's images, there's a lot of stuff involved in that. And so we're kind of taking the our real-time collaboration problem, the RTC problem, onto our hands, trying to solve it a little bit generally using notebooks as the reference implementation, and then put that out there for the world. So I think that's probably the most like notable thing that people are aware of us working on, is trying to get RTC. The hard part about RTC is most of our users are running notebooks by themselves on their local host laptop. They're not running it on a system, a cloud environment with multiple users. And so sometimes RTC feels like we're building it not for our main user base, but I think you'll start to see more services that come out. You'll start to see more research labs taking Jupyter Hub, for example, down, launching notebooks servers for each one of their users, and then hooking them up with RTC. And collaboration is going to be as similar to working in a Google Doc, but instead the doc is a notebook.
Got it. Got it.
So I think that's probably the main thing on our list right now.
That's fantastic. We're almost at the end of the hour. No, Zach, I really enjoyed the conversation. Are there
Me
any
too.
questions that I should have asked that I didn't ask?
Okay. What's the question?
No, I'm saying, are there any questions
Oh,
that
are there any
I should have
questions? I
asked
thought I
that
thought
I
you
did
were
not? Yeah.
thought you were setting up response or for
Mhm.
anticipation and for
Like, I'm
no.
just asking, are there areas that you would like to talk about or mention that I didn't ask?
No. I think we covered it all. I love that I had slides prepared and we didn't even have to use them, because we basically hit all of it as we went. So no, I think I want to go back to that contributing hour. If you go to jupyter.org/community, I believe it is. Um, that's the place to go look if you're interested in just meeting developers. Yeah, it's /community. So jupyter.org/community. If you go there, um, oops, sorry, I just started an infinite loop there. Um, that's the place to go for figuring out what meetings you can get involved in, and find that contributing hour. We do it every other week, and it's really low at time. I mean, we probably have like 5 or 6 people show up every time, so it's really low key, and you can ask questions. And if you don't have questions, you can just watch someone try to fumble around in notebooks like I just did.
Fantastic. No, Zach, I really enjoyed it. Thank you so much for the conversation here. Let us know if we can help in any way. And yeah, I definitely encourage people to join the contributing hours, jupyter.org/community.
That's right. That's right. Awesome. Thank you,
All right,
Arun.
awesome.
Thanks,
Thank you.
everyone.
Bye, everybody.